Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1367, which is linked list in binary tree. Let's see the problem statement. Given a binary tree root and a linked list with head as its first node. Now return true if all the elements in the linked list starting from the head correspond to some downward path connected in the binary tree outs. Otherwise return false. Okay. In this context, downward path means a path that starts at some node and goes downwards. And this is an example. Like this is a tree and the linked list is 4 to 8. Now 4 to 8 is this is 4 and 2 and 8. Not this is 4, 2 and 8 is not there. It should be connected and all the values of the linked list should be present. So this 4 to 8 will be the answer. So we need to return true and if it is not present then we need to return false. So let's see the constants. The number of nodes in the tree will be 1 to 2500 and number of nodes in the linked list will be 1 to 100 and node value will be up to 100. So we will break down the problem in two different paths. First we will think that what could be the head of our answer linked list or answer like our given linked list first element could be the starting position. So what could be the starting position in the tree? So the starting position will always be the value which is same as the head value, like given head value. So all the like for the in this example 4 is the head value, like for the first element value. So all the elements which have the value 4 could be the head of the linked list in the tree. So this 4 could be head, this could be 4, could be one head. So we have to check for each of the head, is this giving the answer, like starting from that 4. So we will check all the values in downward direction, all the values are present or not in the tree. So we will use another function to check that part and we will find for all of the first value, like all of the fours in this example, all of the fours uh, present, like for all of the fours we will check that if it is giving the list or not. So we will break down the question in two parts. So first let me create one function, let's say solve, which will take two parameters. One will be the same as this, one will be the head and root. This function will check the part if it is like from starting from one node, if there is any downward path connected which is same as the linked list, it will check that part. And for all the given all the values which are same as the head, we need to call that solve function. So let's see. First, we will need to check if root is present or not, because we know that head will be present because 1 to 100 will be the length of the linked list. So there must be a head, but as we are using the recursion function, there could be like no head at some point. So we need to check that if root is not there, then we need to return false. Now, if root is present, we need to check if the value of the current node value, like a root current value, is equal to head value or not. So if head value is equal to root value 1, so if it is equal, that means it could be the one head. So now we need to check the this part. If it is equal, so you are using logical and if this part is true, then only the solve will be called. So solve, we need to check for, it will take two parameters, the head and the root value, starting from where we are starting. So if it is, this solve function would give true or false. If it is giving true, that means there is one answer, so we can directly return true. But if this solve function giving false, then we can't return false here, because it is only for one head, because there could be multiple head there. In this example there could be multiple cores. So if this we are checking for one for it, if it is for this example, like let's say for this for we are calling the solve function. If it is giving false, that means we can't directly return false here, because there is another for we have to check for that also. So we can't false here if the like solve function giving false, but we can return true if it is giving true, because there if at least one answer is present, then we can return directly true. So we will return true if it both the options, both the conditions are satisfied. If not, then that means our answer head could be left or right of the current root. So we will return the same function. Now head will be the same, and left or right, root left and root right for the same calling, root right. And we have to use logical or here, because logical and will be for both the options will be correct. But if any one of them is true, we need to return true. So we will use logical or. Okay, that's it. Now we need to check the like solve function. To solve function, first we need to check if head is not there. That means you already finished all the element present in linked list. If head is not there, that means we need to return true, because we already find all the elements. If head is there and the root is not there, then we need to return false, because there are remaining elements present which we can't get in the current tree. So we need to return false here if root is not present. Now if head is present and root is present, then we need to check if root value is not equal to head value. That means it can't be the like one solution, because one of them is breaking that, because we need a connected downward path. If one of them is not satisfying, like if one linked list value is not equal to the root value, then we need to directly return false. Okay, now if it is also correct, like the current root value is equal to head value, then that means the remaining elements would be from left side of the current root value or the right side. So just return solve function. Head will be head next, because we've already find the head we matched with the current root value. So head will be head next, and the root will be root left or right, because the remaining elements could be left side or right side. So I need to check both of them. So if any one of them is giving true, we will return true. So we will use logical or there. So let's see will it work or not. It is accepted. Let's submit it. So let me discuss the time and space complexities of this algorithm. So this function in worst case, it will like this solve function could be called like n times, because if all the elements are same, like let's say all the elements are 4 and the head of the head value is also 4. So for all the element, this function will be called like this will be called multiple times, like all the times for all the values. So it is running n times, and this solve function will take big of n time to check that, because if the like length of the linked list is n, then this solve function could take big of n time. So overall time complexity will be big of n cross m, where n is the length of the tree or all the number of nodes present in tree, and m will be the length of given linked list. And the space complexity will be big of constant, because we are not creating any linked list here. We are just checking some equal to function, or we using some if else condition and using recursion function. So our space complexity will be big O of constant, or you can say big O of 1. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.